Hello students, this is Poonam teacher back with a new video of Science 2, and today I'll be teaching you generation of electricity from solar cells. So solar photovoltaic cells are the cells which converts the incident solar radiation into electrical energy, and this effect is known as solar photovoltaic effect. And the electrical energy which is generated through this energy transformation process is DC in nature, that is direct current. In direct current, the electrons will flow into single direction, that means into forward direction always. And then there is another AC current, that means alternating current, in which the electrons flows in forward and backward in both the directions. So this is the difference between AC and DC. But in photovoltaic cell, the electrical energy will be generated, and the entire process is going to be DC in nature, that is direct current. Now this solar cells are made of a special type of material called semiconductor. Now the semiconductors are between conductors and insulators. Sometimes in some situations they will conduct the electricity, while in other situation they may not conduct the electricity, will act as an insulator. So silicon is used into solar for the production of, or for the creation of solar cell, and silicon is a metalloid. It possesses both the properties of metals and non-metals, and sometimes it acts as a conductor and sometimes as an insulator, and that is why it is known as a semiconductor. Now silicon solar cell of dimension 1 centimeter square generates current of about 30 milliampere and potential difference of 0.5 volt. We all know that electric current is measured into ampere, that is the unit of measuring the electric current, while potential difference is the difference into the electric potential, and that is measured into volt. So 1 centimeter square dimension solar cell will generate a current of 30 milliampere and potential difference of 0.5 volt, and the conversion is given over here, that 30 milliampere per centimeter square into 100 centimeter square is equal to 3000 milliampere, and that 3000 milliampere is equal to 3 ampere, and a potential difference of 0.5 volt. So we have to remember the thing that potential difference is available from a solar cell is independent of its area. So whatever potential difference will be created, that will not be depending upon the area of the solar cell. And see what is given over here, the photovoltaic effect. That means the incident solar energy is going to be converted into DC electric power. So this is going to be the photovoltaic effect, as I've taught you. Now see what is given over here, solar cells in series. In series means when the solar cells are going to be present side by side horizontally. So these are going to be arranged into series. Now what happens when the two solar cells are connected into series? The potential difference obtained from this combination is addition of the potential difference of the individual solar cells. That means the total potential difference of these two solar cell will be equal to the sum of the potential difference. Sum means total addition of the potential difference of the two solar cells, like this. That means V total is equal to total V is equal to V1 plus V2. This V1 means potential difference of the first cell, and this V2 means potential difference of the second cell, like that. But the total current will be equal to the individual current. That means total current is equal to the current of the cell 1 and then the cell 2 again. So there is not going to be addition between the currents of the cell, but the total potential difference is going to be the addition of the potential difference of these two cells. And when the solar cells are going to be arranged into parallel form, that means two solar cells are going to be present into vertical form side by side, or into vertical manner side by side, reverse things will take place. As here the total potential difference was the sum of the potential difference of this cell 1 and cell 2. Here the total potential difference will be equal to the potential difference of the individual cell. That means total V is equal to V1 is equal to V2, but the total electric current of the cells will be the summation, or will be the addition of the electric current of the cells, cell 1 and cell 2. That means I is equal to I1 plus I2. So now what happens into a solar panel, let's see, this solar panel will be made up of various cells. So many cells are there. So now in this way, by connecting many solar cells in series and in parallel, solar panels generating required current and potential difference are made. So for the creation of any solar panel, the solar cells are going to be arranged into parallel and into the serial form. That means the solar cells will be arranged in series also and in parallel manner also, and then we'll generate the required current and the required potential difference.